All right, calculus, we're on day 2 of curve sketching, and we're just going to continue to add to our toolbox. We talked about increasing and decreasing yesterday, and so we're just going to be just a little bit broader and mention again that those are called critical points, but specifically where the derivative is 0, we have a turning point, or when it's undefined. We have critical points there that may or may not be a turning point. Every relative maximum or minimum occurs at those critical points. So for this function, y equals x4 minus 8x cubed plus 18x squared, we want to know where the critical points occur. So let's look at the derivative and see where it is 0 or possibly undefined. So our derivative is 4x cubed subtract 24x squared plus 36x. It is not undefined anywhere, so I am looking for critical points by setting the derivative to 0. So when my derivative is 0, and you know what, this is nicely factorable, so let's look at this. I would have 4x x squared subtract 6x plus 9. Ooh, 0 is 4x times x subtract 3, x subtract 3. Awesome. So at x equals 0 or x equals 3, I have critical points. Let's fill in a nice pretty chart. So here are my intervals. 0 is a critical point. 3 is a critical point. So this is my x. Less than 0, between 0 and 3, at 3, greater than 3. So, oh, you do a neater job, okay? At 0, less than 0. So I know I have critical points that are zeros. So I'm going to use my derivative to find whether it's positive or negative. So if I put a value less than 0, so let's say I choose, I should write the derivative here though. Derivative. Okay, so let's choose a value less than 0. Let's go with -1. So if you put a -1 in there, you get -4. -1 subtract 3 is -4, but it's squared, so that's positive. All I care about is sign. I get negative. If I put a value between 0 and 3, so let's say it's +1, I have +4, and then a negative squared, I get positive. All I want is the sign. Greater than 3, say that I chose x equals 4. I have a positive times a positive, I get a positive. So my critical points are here and here. Let's see if we can figure out what they are specifically. So my function, f at x or y, whatever, is decreasing because the derivative is negative. It is increasing, and then, oh, weird, increasing again. So if you decrease and then increase, you will have a minimum. But if you increase and then increase again, something weird is going on here, but it is not a max or min. But it's still critical. Nag, nag, nag. Okay, let's see what we can do about graphing this. I'm going to come up with a few key points just to anchor ourselves here. I know the function at 0 would be a good place to look, and the function at 3 would be a great place to look. It would be nice to have a point in the different intervals, so I'm going to go to the left of 0. I'm going to go in between 0 and 3. And to the right of 3, and use the original function to get the key points. 0, 0. Let's write the function down because I keep forgetting. x4 subtract 8x cubed plus 18x squared. Okay, if I put a 3 in there, 81. 27. Don't trust me, you better do it yourself. -1 is +1, +8, plus 18. Getting 26. 111. and 432. Okay, key points. I'm going to have to change my scale. Let's go with 10, 20, 30, 1, 2. All right, this we can do. 0, 0, 327, negative 127, 111, 432. So I know I have a critical point at 0, and I know that it's a minimum. And that shows with the points we looked at anyway. But I know I have a critical point up here, and it's not a maximum or minimum, but something is definitely going on there. So very, very roughly, before we use other tools in our toolbox, we have a different type of critical point in two different places. Okay, second example might seem a little silly, but that's okay. We want the relative maximum or minimum of, oh, that's weird, of f at x equals x cubed using the first derivative. So our first derivative would be 3x squared. When is 3x squared 0? Just at 0. So for our intervals of interest, we want to look to the left of 0 and to the right of 0. We know that at 0, our derivative is 0, and that is a critical point. If I use my derivative and use a value less than 0, so let's go with x equals negative 1. And I put it into the derivative, I have a positive 3. If I put a value greater than 0, so say we did x equals 1, you don't have to write that bit down, but you want to put a positive value in there, you still get positive 3, you still get a positive. So this is a critical point. Something interesting is going on there, but we're going from increase to increase. So it is not a relative maximum or minimum. So we've got this interesting point. And we know things are going on, but we're going to be increasing as we go to the right and left. We know this cubic. We know it has this shape. And so we know that's a critical point, but not a max or min. Third example. If I have f at x equals x plus 2 to the power of 2/3, I want to find some critical point. So I know that's when the derivative is 0, or possibly when the derivative is undefined. So let's work down here. F at x equals x plus 2 to the 2/3. So my derivative would be 2/3. Reduce the power by 1. Don't forget the guts. There aren't any interesting guts, just 1. Blah. Another way to write this would be 2 over 3 cubed root of x plus 2. So we can't have a 0 on the bottom. So this will never be equal to 0, but f prime x is undefined when x is negative 2. So that is a critical point, and the only critical point. So we want to look to the left, and we want to look to the right and see what's going on. So my derivative is undefined here. If I look at my derivative and I put a value in of less than negative 2, so what do we do? Negative 3? I'm going I'm going to have on the bottom cubed root of negative 3 plus negative 1. Cubed root of negative 1 is negative 1. So I have 2 over negative 3. I have a negative. Say that x is greater than negative 2. Well, you can choose anything you like. Let's go with 0. So if you put a 0, we have the cube root of 2. Weird, but positive. We end up with a positive here. So we have decreasing, and we have increasing. So this is a minimum. But if we have a look at Desmos for this particular function, at negative 2, we certainly have a minimum, but we have a cusp, and our derivative is undefined at that point. Some key points. F at negative 3 is 1. F at negative 1 is 1. And f at negative 2 is 0, where it's undefined, just to get ourselves anchored.